Welcome back to Dan91's Garage, where on this episode we're going to talk about how to wire in the DET3 piggyback ECU to the Toyota Starlet factory wiring loom. So if you want to check the purposes of the wire, thankfully Toyota have printed their codes on the circuit board at the base of the pins from the socket. So you just need to take the cover off. That's 4 screws, 1 in each corner. And if you look at the pins that come off the socket, you can see that next to them, it's got the codes printed on it. I'll cut in a picture just in case it's a bit too blurry. We've already covered the difference between a splice and an intercept in the previous video, but just to go over it quickly, a splice is where you connect the end of one wire into an existing wire, and the intercept is where you cut the original wire on the car wiring loom and then have to wire in 2 wires from the piggyback, 1 to each of the cut ends. The first wire is going to be the switched 12 volt to power the piggyback ECU. Obviously you need to do this with the battery disconnected so there's no chance of frying any of your electronics while you're unplugging things and chopping wires. And that is clipped into number 1 position of the DET3 plug. And you have to splice that to the wire coming from the position of A9 on the small plug on the Toyota ECU. The colour of the wire on the Toyota loom should be black with a yellow stripe. The code inside the ECU should say +B, and that is the Toyota ECU's switched 12 volt supply. We'll skip on down to the next splice because there's only 2 splices, and that's for the ground of the piggyback. So pin 11 on the DET3 piggyback plug, you need to splice that wire into the wire coming out of B24 on the large plug of the Toyota ECU. The wire coming out of that should be brown, and the code inside the ECU on the circuit board should say E1, and that is the computer ground. So the next 2 wires are going to be intercepts. The first one is to control the ignition. So you need to find the wire coming out of position B6 on the Toyota factory ECU plug. The wire should be black with a white stripe, and the internal code inside the ECU should say IGT, and that's the ignition timing signal sent from the ECU to the ignition module in the distributor. So cut that wire and then you'll have 2 cut ends. You need to leave a suitable distance to the plug obviously, so about 75mm should do it. So once you've cut the B6 wire, you'll now have 2 ends, one from the Toyota ECU and one going into the engine bay. You need to connect the one from the ECU to pin 9, as that's the ignition in for the DET3 unit, and then you need to connect the other end that goes to the loom to pin 6, as that's the ignition out for the modified signal from the DET3 unit. And the last wire is an intercept as well, and that's the wire coming from position B4 on the Toyota ECU plug, and this is for the map sensor. This one's a bit different to the ignition one because the signal is sent from the map sensor in the engine bay to the ECU. The wire in this position should be light green. The code on the ECU board should say PIM, and this means map sensor. So once you cut the B4 wire, you'll have 2 ends, one for the ECU and one for the engine loom. You need to connect the wiring loom end to pin 13 because that's the analog input for the DET3 unit, and you need to connect the ECU end to pin 17 of the DET3 because that's the analog output for the modified signal of the map sensor. So this is the completed plug and play harness, and I've obviously attached the DET3 piggyback ECU to it, and I've also attached it to my spare Toyota ECU. So some of the connections are the same, but some of them are a slightly different configuration. So we'll start from the beginning with this one as well, just in case you want to make a plug and play loom instead of wire it into your car. So as we started off with the power wire, which comes from pin 1 of the DET3 piggyback. This thing goes round and is spliced into A9, which is this wire on the A plug, which is a small plug here. So we spliced that in with an open barrel splice and then covered it with heat shrink. Then we'll go on to the ground, and that's from pin 11 on the DET3, which is directly underneath pin 1, which was for power. And that goes around and splices into B24. And B24 is on the big plug. It's third one down on the back row. You can just about see that in there. So that's spliced in with a second ground, and that's the power ground. So if you're going to control a boost solenoid or any other power accessories through one of the power outputs, you need to add an extra ground in as well. And the power ground is from pin 19, and that goes around and is spliced into the same open barrel splice as the normal ground. Splices into B24. So we've got 2 into 1 there. Then we come on to the intercepts. So we've got the same IGT intercept, but instead of having a wire here which we cut into and then attach to the loom end or the ECU end, I didn't see the point in running a wire there and then cutting it, because then you've got an extra set of joins in the middle, whereas you can simply add the wires directly to the socket or to the pin. So for the IGT wire, that comes from the ECU and goes into the DET3. So on the wire from pin 9, I crimped on one of the female receptacles that fits into this plug. So that's the B6 wire in to pin 9 on the DET3, and then the modified signal out from pin 6 to the socket position B6. Then we've got to do the same with the map sensor, but obviously remember that's sort of the other way round. So the map sensor signal is coming in this way through the loom into the socket. So on position B4, we solder the end of the wire that connects to pin 13 on the DET3 piggyback. So now we have the map sensor signal going in. We then modify it in the fueling table and then send it back out of this on pin 17. We then crimp that onto a pin that goes into position B4 on the plug for the ECU. We now have the modified signal connected to the ECU. The DET3 itself has 4 analog inputs. So those 4 analog inputs are essentially for things like the map sensor, coolant temp sensors, intake air temp sensors, things like that. So because we've already hooked into the map sensor, that's how we're going to adjust fueling, and that map sensor is also going to be the load signal to move us around our tables. I'll go into a separate video about the computer settings. We're just going to talk about the hardware for today. So you've got 4 analog inputs. Ignition is separate, so that doesn't count as one of them. So we've got the map sensor going in on 1 from the Toyota engine loom. The DET3 Plus has an internal map sensor. Now that is hardwired onto the board, and the input for that is analog 2. So you can't actually connect a wire into position analog 2 on this, which is pin 14, because it's already occupied by the internal map sensor. So you lose one of your inputs by having that. So on to the next is analog input 3. So what I'm going to do is I'm obviously going to have a wideband O2 sensor to monitor how rich or lean the exhaust gases are. And you might as well pipe the data signal for that into the DET3 ECU as well, because it's a data logger. So not only do you get to read it on a dial on the dash, but you can also send it into this on pin 15, and then you can use it for data logging and also for some of the corrections in the fueling and ignition table should you choose to. For the wideband O2 data signal, you're also going to need a sensor ground. So I've tapped into the sensor ground as well. So that's just a spare wire here. And I've connected a little spade connector to that. So when I've wired up the wideband O2 signal, I can connect the signal ground to this. And the sensor earth is B16. So I've spliced into the wire that's in place on the patch harness. So I've got one input left, and that's input number 4. And that is pin 16. And I've spliced that into the wire B5, because that's the intake air temp sensor. So I thought that would be good to monitor the intake air temp sensor and also be able to data log it, so I can see if all of a sudden, for example, we start to get detonation at a certain point during a pull, we can then see what the intake air temp sensor was doing. The other thing as well is you can use that for one of your corrections, because there are some 2D corrections as well as 3D corrections. So you can use that as a 2D correction as well. So if the intake air temp gets too hot, you can use that, for example, to pull out a few extra degrees of timing and make it a bit safer. So we've already covered the wideband O2 in, but I've got one more wire left. And that is coming from pin 20. Now that's power output, and that is what's going to control my boost solenoid. So that simply attaches, I'm just going to put a spade connector on the end of that and then connect it up to a boost solenoid. So in the piggyback ECU, you have a PWM table, which is a pulse width modulation table. So that allows boost control. So you'll have another table, and then you can basically tell it how much duty cycle to put in to the max solenoid that will be controlling the boost level. So this unit not only controls ignition, fueling, and data logs, it can also, control solenoids for boost control, nitrous, shift lights, all sorts of things. And the unit with the leads is less than 250 quid. I mean, to me, it seems a bit crazy to not use one because it's so cheap, and it basically replaces 3 different devices. So it's a piggyback, it's a boost controller, it's a data logger, all sorts of exciting stuff. So I've only got 2 wires left to explain, and these are these 2. Now they're from position B10. Quite a lot of this stuff goes on the B plug. So this is from position B10. And what I'm going to do is put a small switch in there, a small rocker switch. And the signal from the narrowband Toyota O2 sensor is sent in along that. So if I put a switch in there, I can turn on and off the factory O2 sensor to prevent it doing any sort of fuel trims in closed loop. So when the engine's in closed loop, it refers to the narrowband oxygen sensor output to know whether it's rich or lean, and then it adjusts fueling to either take away or add fuel depending on the condition. Now the problem with that is, if at that particular point in the map you want to put fuel in with the DET3, the narrowband O2 sensor is going to see it and then try and pull it back out again for you. So you'll never get the right fueling or the desired fueling, because the Toyota ECU is always going to try and pull it back to 14.7 when it's running in closed loop, or whatever its specified target is, and you might want to run it perhaps a bit richer at 12 or 13, for example. So by putting that switch there, I can turn off the narrowband O2 signal, and that way the Toyota ECU won't be able to adjust fueling in closed loop. That way I should be able to add whatever fuel I want wherever I want it to be, because I'll know what the air-fuel ratio is from the wideband O2 sensor. So that's about it, really. Hope you enjoyed it. My name's Dan. This is Dan91's Garage. Don't forget to like and subscribe, and I'll see you on the next episode.